right, would anybody like to be a note taker today? It's a wonderful time. The best part here is everybody's name shows up on the screen, so you don't even have to guess anymore. It's wonderful. Does anybody want to be a backup as well, just to help make it a little bit easier? Thank you both. All right, you've got plenty of backup. The main idea here is basically summarizing decisions, key points. You don't need to take every single word that anybody says. We have it on YouTube. We can always watch it back. So especially anything that we decide on or any kind of conclusions from the discussion are the most important thing.
And of course, to use the notepad. Use the notepad. It's linked from the agenda. Thanks.
Thank you, David. All right. Okay, let's get started. Welcome to the Happy Working Group meeting at IETF 123. This session is being recorded, and please make sure that if you have not yet opened up your phone or your laptop this morning, please open it up and go scan the QR code or log in to MeetEcho so that you can join the queue. When the time comes to do that, you use the hand button to join the queue. If you're remote, you use the microphone and optionally the camera icon to send video. This is the IETF Note Well. Please make sure that you read it carefully. These are the conditions under which we participate in the IETF. Please take special note of the IPR disclosure requirements, since it means that you may have some responsibilities. And this is the code of conduct. We operate under a code of conduct in the IETF. Please make sure that you're treating everybody else with respect. And if you experience or observe any place where that code of conduct is not being followed, please reach out to the chairs, the AD, or the ombuds team. We've got some helpful links here. And this is our agenda for today. So broadly, we're going to put a bunch of time into resolving some issues that are opened against the main Happy Eyeballs document. I think judging from the slides so far, that's looking like there's going to be some good discussion in there. Then Dave is going to give us a brief overview of some Happy Eyeballs testing that's been done, and we're going to have a good chat about that. We're going to look a little bit more at reporting with network errors, and then we're going to wrap up. Would anybody like to bash the agenda? Lovely. All right, with that, I think we have, oh, that's our wrap up. We have Tommy to come talk to us about the main document. Yep. So that we can hand off.
All right. Hello, everyone. Tommy Pauly from Apple. I'll be starting our presentation on the main draft, and then partway through, I'm going to hand over to Nidhi to take us through some of the open issues. All right, so since last time, we have adopted the draft, which is great because that was kind of the point of doing the working group, was to figure out how do we do these things. And so thank you for that. Thank you for the comments and feedback last time. Is this working? Did you pass it? There we go. Great. Okay, so what are we going to go through on this draft today? First half, I will take us through what are the updates that we did from the 0.0 version, which was essentially the version that we had adopted till now. And then Nidhi will go through all of the currently open issues that we want to get your feedback on. Although I would still like your feedback on what changes are going into 0.1. So as we go through these things, please do get in the queue and say if this makes sense or not. All right. So here's a brief overview of what changed in the 01 version. There are essentially three sections of the document that got some major rework. First is the first step of the algorithm, which is around the asynchronous DNS resolution, how you kick off the queries, how you handle getting queries answers back for DNS. That got a lot of love and attention, and we'll go through what those changes are. We also did a big rework of how we do the address sorting based on some of the discussion we had last time around the different priorities and application concerns and how those may interact. We also tried to do a better job of discussing IPv6 mostly networks, how we handle Pref 6.4, and try to get the v6 only network guidance up to snuff. And then there's also some editorial cleanup, but we're not going to go into too much of that now. All right. So as just like a recap for the overall algorithm, there are three big steps. There's that asynchronous DNS resolution. There's this step of sorting your addresses or sorting all the answers you have received. And then there's the actual connection establishment, which is this staggered but kind of continued in parallel connection establishment. It's essentially those first two sections got a lot of rework recently. We didn't change much on connection establishment. I imagine we will need to do that work. That just hasn't been done yet. Okay. So for the first bit, asynchronous resolution, it used to be a lot simpler. So in Happy Eyeballs v2, we just had A records and quad A records. We only had to talk about when you're on a dual stack network, because if you're on v6 only or v4 only networks, it was simple. You could just do one. However, once we add in another record type, so SVCB, HTTPS, into the mix, that does make it more complex. You have to decide which queries are you even sending. Like, is it just A and quad A? Is it A and quad A and HTTPS records? Is it just A and HTTPS records? Is it just quad A and HTTPS records? And so, like, there's decisions to make, and this makes the text more complicated. And then there's also a decision of when do you move on to the step of actually sorting and starting to kick off establishment? When do you know when you have enough? So first, about kicking off the queries. So if you are on a v4 only network, you kind of only have to send out the A query. You're not going to be able to do much with v6. You do A and quad A on the dual stack network. And then if you're on a v6 only network, I think that should say quad A or A plus quad A. Sorry, typo. You can send out just quad A, or realistically, because we may have Pref 6.4, we may not have a DNS 6.4, you need to send out A and quad A even on a v6 only network. And then there's a decision of should you query the HTTPS record or the SVCB record that's applicable for your type. So for HTTPS records, you should send that out if your application uses HTTP or WebSockets, some URL that is in the HTTP family. For SVCB non-HTTPS records, those are going to be if you're using a very specific application type, and so your application probably knows upfront whether or not it needs to do some special SVCB query. And then for the order, so like you essentially filter out like which queries do I need to make, and the recommended order, just because you have to send the packets in some order, is your SVCB or HTTPS query, then your quad A, then your A, but they really all go out kind of as one flight. So that's the current description. I think this works. This is roughly what we were suggesting that we would do last time. Let me know if you have concerns. Jen.
And Jelinkova, I think I sent it to the list, and I think Andrei here might have some comments as well. It would be nice to be careful with defining what V4 only or V6 only means, because the cases I'm concerned about is when you have base like normal network and you have VPN without default. And draft currently correctly talks about cases when you have V6 only network and V4 only VPN, but apparently there are opposite situation when you have V4 only network and VPN, which you try to use to access V6 only internal resources. And this, for example, currently does not work in Chrome, for example, because unless you install a specific V6 route to Google DNS over V6 into your VPN, because otherwise Chrome like, I am on V4 only network, I'm not going to even send quad A. So maybe we want to talk about how you define the connectivity. Do you really need default, or you have an interface with that connectivity, and so on, right? Because there are corner cases which a lot of customers actually complaining already.
Right. So like that's essentially the distinction between, I guess, do you have, so one option is, do you have a default route, but that obviously has problems. You could still talk about routes and say, do you have some non-local route, but that's still probably problematic. And then you could have like, do you have an address assignment that you can send from? And maybe that's a safer thing to do. Andre.
Andrei Tsodka, RIPE-NCC. Basically, on this, I looked through the document where it mentions connectivity, and there are basically two occurrences of it. First, it says what you should query. That's this part that you are talking about now. And second is what is your preferred address family? They're based on connectivity. Basically, if you have V6, then your preferred is V6. If you don't have V6 connectivity, then your preferred connectivity is V4. And I believe these two should be treated differently, because for the former case, what to query, the whole purpose of this protocol is to go around weird networking issues. Therefore, it should be completely safe to do quad A query even on V4 only network, because what possible harm can happen? Well, maybe the DNS query will not succeed, but that's the point of this protocol, to not to cause an issue. On the other hand, in the second part, where you are determining what is your preferred address family, whether it's V4 or V6, there I think the good choice is default gateway. If you don't have V6 default gateway, then V6 should not be your preferred address family. Does it make sense?
I think that's interesting. I guess.
I think it needs to be written down.
Yeah, I think it'd be good to see a written proposal. So for the second part, if I get back a quad A answer and that thing is routable, even if it's not going over a default route, if it's going over some split route for a VPN, like I don't see a reason to not prefer it. I think that we actually shouldn't necessarily downgrade the V6 preference if I do have a viable route to one of my V6 resolved options.
No, I mean this is basically the case of let's say if you don't have default route on V6 and you do resolution, and you will get a quad A answer, and it will fail because you don't have default route. I mean, like, you know, I'm basically trying to avoid this 50 milliseconds penalty for not finishing the query. But yeah, there are many corner cases. This was just like the idea that I got about this. So I feel like, yeah, definitely like defining what you mean by connectivity would be helpful, because this is something that everybody can have different opinions on.
Sure. One other bit, and this is just also kind of for posterity and the notes, if we're looking back into this issue. I think the other bit that this interacts with is what I'll get to next, which is like waiting for DNS responses. So if I do not if I don't have a default V6 router, like I don't think I have normal connectivity, but I toss over a quad A query anyway, which may be okay, I may not want to block on it or delay going forward.
Yeah.
If I think it's probably not going to be useful anyway, and it was more of a Hail Mary.
That was exactly my point with this thing. Basically, you don't wait for quad A if you don't have default root. You
Right.
do send quad A, but you don't wait for it because you don't have default
Yeah.
root, so you expect that it's not used.
So I think that's more about when we move on from the resolution step, less about the
What to
connection
query.
establishment. Yeah. Thank you.
Alessandro Gadini, Cloudflare. Mostly a question. So the SVCB RFC also to some extent specifies what the client behavior is. So for example, it talks about CNAMEs and stuff like that. So I wonder how much of that should be mentioned here, or
So I don't go into it too much on these slides, but the text does talk about how you follow, like, for example, the SVCB aliases, and like this is trying to just refer to the SVCB
right?
document and
Yeah,
say,
so
just do that thing, which happens to be, you know, if you get the name, then you have to resolve the sub things, and if you have an alias, you need to resolve the sub services, and then you do the A and quad A off of that.
Yeah, I was looking for the reference in the happy draft to the section in the SVCB RFC, but as far as I can tell, it only mentions ECH. It might be that my search.
Yeah,
skills
we
are
definitely
not so-
we may not reference that specific
Yeah,
section.
yeah.
We may just reference the entire RFC. We can make it more specific there,
I-
but I believe like it is attempting to just follow what is there, and if you see any discrepancy, drop a issue or PR.
So the SVCB RFC does say, I think something like you may use something like API balls v2 to select, you know, the address or whatever. So maybe there's nothing to do, but I don't know.
Yeah.
Does this need to update that RFC to say use API balls v3 instead? I don't know.
Yeah. Unless that is a normative thing in SVCB, which I expect it's not, then I don't.
It's a may, like uppercase may. So maybe
Okay.
yeah.
Fine. Yeah. I'm hoping that it does not need to update anything. Like, you may do that, sure. That seems fine. Okay. All right. So the other half of asynchronous resolution is when to just move on. You're done waiting for stuff. Because ideally you get everything back super quickly. You get your HTTPS and your quad A and your A back in 1 millisecond. You're good, but that's not always reality. And previously, again, this was much simpler when you just had 2 queries you're waiting for, and you say, essentially the old guidance was, if you get quad A first, start using it. And if you get A first, wait like for some resolution delay timer up to like 50 milliseconds for the quad A to come back so that you actually have a v6 address. That was nice and simple. Having the 3 is like the combinatorial explosion of possibilities gets too complicated. So the attempt here is to write just like a logic state machine that means we don't need to enumerate every possible case. I do intend to, I think the document has a section of like, we should give examples of how these actually play out. And so we will want to enumerate some of those, but I think for the algorithm description, the goal here is to have just like this logic as opposed to a full enumeration of all the cases. So what is the logic we're trying to have? And this is why I want to get people's take on if you see a problem with this. So you can move on in 2 cases, and moving on means like you start sorting and connecting. So in one hand, you have some positive address answers, and that means like you have some actual like non-empty address answers. Like either you got an A, quad A, or a V4 or V6 hint from SVCB. So like you know some address, condition 1. And you have either a positive, so like an actual address, or an explicit negative answer for the preferred address family. So like for V6. So like you actually got a V6 answer, or you're told there is no V6, but based on the first condition, you do have a V4 address. And you either got back a proper HTTPS record if you asked for it, or you got back a negative answer that there is no HTTPS record there. So like this is kind of like the ideal case that like you have all the information you want for HTTPS plus your preferred address family, or the non-preferred one, and you know that you don't have anything for your preferred address family. So that's one case where you can move on. And then the other case is that you have some positive address and the resolution delay timer has fired. So that means like implicitly that like either you didn't get any HTTPS record back yet, or you only got back your less preferred address, but you haven't heard anything about the other address family. So that is the proposal to essentially keep the spirit of the current Happy Eyeballs v2 behavior, but allow it to expand to include the SVCB responses. I guess the one thing I'll note is like this is not taking into account any strong application requirements of like I must have ECH in it, or anything where you're trying to say like either I get the HTTPS record or bust. I think that's a separate issue that we have that we'll want to talk about. But I guess with that aside, does this make sense to people? Are there any issues with this, Alessandro?
Alessandro Ghedini, Cloudflare. Just a question. I don't have a lot of experience on like client side things, but my understanding is SVCB doesn't necessarily work on all platforms, or you might not have like your DNS client library working with like weird queries or whatever, like newer. Sure. So I wonder where does that fit into? Would that appear as like a timeout or just like a straight up error? Which
no, I guess, and maybe the wording can be more clear. This is like if you were able to send the query, if you sent out the query for HTTPS, right, like if your thing supports it,
yeah, that
then
makes sense.
Make sure you get it or you don't. If you don't even support it, then like that, like essentially immediately is a negative response because it's a no op.
For the when you say move on here, is this move on and then asynchronously you might also, if those queries come in later, you might also take action on this, or is this the you move on and would kind of never look at anything that comes back afterwards?
Great question. So just like the current, or like the existing Happy Eyeballs v2, you always respect answers that keep coming in up until the point that you actually have a connection and you're like done with it. But yes, this just means like, when do you get to start sorting your initial answers and start making any connection attempts? And if another one comes later, great.
And is there any thought of that, like 50 milliseconds, is that 50 milliseconds in the current draft something that's a fixed number, or is this something that we intend to be adaptive to deal with network conditions where that could end up being kind of in the noise versus not in the noise?
I think it's fine if it's adaptive. This is something that the V2 draft just kind of had like, be your own thing. Like this is really just to account for your DNS recursive resolver is sending you back the answers, and we don't want to just do silly things if it just happens to send just the A answer back. It happens to reach you like 5 milliseconds before you would get the quad A and the HTTPS records, but you're like, I guess I'm on a V4 only server and I have no HTTPS. I'm just going to start doing that. Like just like give a bit of a grace period for the recursive. And presumably, since you sent out your DNS queries all in the same flight, modulo some packet loss there, there shouldn't be like full network round trip differences between the different records coming back.
I guess unless there's a lot of jitter. I guess a lot of jitter on the network, like this hotel network, could do that.
Right.
It's
a good point.
And there might also be a thing of thinking of whether, like in the relative scheme of things, if that first is looking at that as being relative to how long it takes that timer to come back. So if you like if it takes if the first response takes 200 milliseconds, then it might make sense to wait a little bit past, or have it be a factor of that. But I think that's probably worth exploring a little bit.
Yeah, although that could potentially have the effect of exacerbating a case where it was already slow, and now you're just ballooning it up.
Yep.
Hey, Jeff.
I think Jeff was actually next in the queue. Yeah.
What we do.
I couldn't
on-
read the queue, sorry.
It's hard to see it. On the right-hand side, this whole resolution time delay of 50 milliseconds, it assumes that either there is no DNS response forthcoming as distinct from no data. And to my mind, that always struck me as an anomalous delay that was unnecessary. If the record isn't there, it's no data, it comes back, quickly. Hanging around for 50 milliseconds, just seems to me to be 50 seconds, it's futile. And I just don't grok anymore why that 50 milliseconds actually has a useful role. To what extent does no answer really feature as distinct from a positive no data answer?
Can I jump into as author?
As person who added the delay.
Jeff, jumping in as the person who added this 50 millisecond delay to Happy Eyeballs V2. It was you. Yeah. So the idea here is that, and this dates back to Happy Eyeballs V2 where we just had A and quad A. So you send both your queries and then you get the response for the A but you're still waiting for the quad A. And what do? In Happy Eyeballs V1, you would just wait indefinitely until you got the quad A. And this is my packet might have gotten lost and my DNS stack is probably going to wait a full second before it sends a different query. So after 50 milliseconds, I'm going to say this packet isn't coming. So let me just run and start the TCP SYN for V4. But you still leave it open that it might come back, it'll fill your cache. But that was the idea of, let's not wait a full second when we have an address that's perfectly usable.
I was just thinking 50 is a very big number. I would be more aggressive, but that's me.
Oh, I think we started at 25. We called it the I like IPv6 is this much number.
Right. And so this is something I think, and to the point, I think actually, like in our charter, we talk about trying to be more measurements driven. Like, would be great to do some new data collection on, because I think at the time when we did V2, on our machines we ran some data, but like I think it'd be great to get some other data points of, realistically how small can we make that, and still in the 90th percentile of cases when you don't have an actual loss where you're going to need that full second retransmission. Are you going to get it? So like, I imagine 1 millisecond, too short. 5 milliseconds, probably too short. 50 milliseconds is long enough. Maybe it's a little bit too long. And so, yeah, we can tune that in there. And I think doing some new data collection across different networks would be really interesting.
Jelinkova. Thank you, Tommy. You basically almost answered the question I was going to ask. I was curious, right? Do we have any data for normal cases, not like real bad packet loss or jitter? How different those approaches would be, right? Where they converge, right? Or how much actually does it really matter, and which condition it does matter?
Right. So again, I think a lot of the data is old, so we should get new data. But I think the difference between them, realistically, this case, when you trigger the one on the right, the goal is that you trigger this because there is loss. Like that if you were to not do this, you would end up waiting a second or so. And those do exist. And so we just want to make sure that we do the left-hand one as often as we can. The ideal case is that we do the left-hand one, except for the case where you would wait a second.
Sorry, I will ask a question because I read a draft a long time ago, some time ago, so I forgot. Is this 50 milliseconds waiting after you get the first response, or from the beginning of the request?
After you get the first response.
Okay.
So you may, to your DNS resolver, you may have a 300 millisecond delay,
Okay.
but this is just like between when they send those 2 answers back of the A and quad A, or the 3 answers back, how much time between those in that flight do you allow
Yeah,
for
yeah.
jitter?
That makes sense. That makes sense.
Jordy?
Yeah, Jordi Palet. I think what some people may be missing here is that the 50 milliseconds is to make sure that we give some preference to IPv6. That's the first thing. But also, if I recall correctly, it's something depending on the implementation. So implementers could decide something else, right? And I think also it's mentioned in the draft, and I think it's really important that maybe updates of the implementation can lower this timer. So I think it's good enough, and I'm not sure if going now below 50 milliseconds, but I think we still need to give some preference to IPv6 at this stage.
Yeah, yeah. No, that makes sense. Yeah, and just like in general, I think anytime we're talking about numbers, the algorithm and the documents approach is it is a configurable value that has a recommendation in the draft. And I think to Jeff's point, we should revisit the recommendations and make sure that our recommendations that we come out from the group with are like the best ones we have for the current internet, but it's always going to have that asterisk of like things may change.
With no hats, we were just saying some data would be nice. So I took a quick look, and P50 is somewhere around 20 to 40 milliseconds for mobile devices wandering around the world. And P90 starts to get up into like the 100-ish milliseconds.
A clarified question, P50 of what?
P50 of how long it takes for you to receive all of the records.
Okay, but that's
Not
not
just
what,
a single one, yes.
But this, what you want here is the time between when you receive the first one and the time when you
Correct,
receive
yes.
the last one.
Of course.
Yeah, because the data at the time was, it was very in the single-digit milliseconds, just due to packet reordering, very commonly.
Yep.
Even yeah.
Tim.
Yeah, just to say on Geordie's comment, it's section 9 that does say these values can be changed. But it's clear that from what Tommy and others have said, we should try and get some real world data. Also, I'm just looking at section 4.2 with regards to the right-hand side of this slide. It does say there, the resolution time delay is a short time that provides a chance to receive preferred addresses along with service information. So it's not just about addresses, it's the service information as well. So one of the, I'm not sure which you mean. I think you mean and service information, but just make sure that's the case.
Right. It's that the bottom clause there. The some
Oh,
answers
right. Sorry, I didn't see the
from
green
the
box.
HTTPS record.
Sorry,
Yes.
Tommy.
No, that's great. Ben?
That answers that. Thank you.
Thanks, Tim.
Hi, Ben Schwartz, Meta. I think we have consensus on what this text is supposed to mean, that like you get v6 in and you attempt a connection on that. A few milliseconds later, you get v4 in. You know, there's some delays. Maybe you'll also attempt a connection on that if you don't, if the v6 connection establishment is sufficiently slow, or vice versa. If v4 in comes first, maybe you'll hold off on initiating connection establishment for up to 50 milliseconds, but then you'll start. And then if v6 comes in shortly after that, you'll immediately also in parallel start a v6 connection attempt. So I think we all understand. Well, sorry, I think we have consensus on what we want the behavior to be. I don't think the text actually says that. It says it says things like we should move on to the next stage of connection establishment.
Correct.
Which you know, a naive read of this section makes it look like, well, you know, at this point you terminate, you know, and it doesn't really read like, and you keep waiting in case less preferred options come back, because you might need them.
Okay. I know somewhere like other parts of the text definitely do say you keep this open. And so maybe if you want to drop just like an issue or PR to reiterate that in some of the cases when we say move on, that would be great. Just to make sure it's very clear to people.
Eric, did you have a final comment?
Yeah, on the on a slightly different topic, in the lower left one, does this need to think about whether the HTTPS service B record that's returned is usable from an address record perspective, or do we deal with that in the next pipeline stage? Because it's possible that the one that you do get back has a target name, only has a target name that you don't yet have a response for.
Right. So, if you have address hints, good on you. I think very specifically, like if you had only an alias record of SVCB, like that's not enough to satisfy the bottom left. If you have, I think that's a good point that we should clarify in here. If you get a proper service record, but it does not have address hints and you don't have any addresses corresponding to it, so you don't have the corresponding A or quad A records, then I think that should not satisfy this condition.
Yeah, I think that might be something worth clarifying, because it didn't look like the current text yet covers that.
Yeah, I think that's a good point. Like that would be a really unfortunate scenario, because it kind of implies that like if you were satisfying the above ones, this means that like you got back an SVCB response, but you don't have one for the dot special name. Like you only have ones for other services, which we do treat a little bit in the text, but it's just like really unfortunate. Like you only have service information about none of the addresses you have, and you have no addresses for the one service you do have. So yeah, I think that is an edge case that we should call out of like, you should still keep.
Yeah, an alias mode might fall in, also count in that category, and then and maybe
yes,
that, like,
alias is a case. If you only have an alias, I think that's a case where you keep waiting there.
Yeah,
and maybe in that case you need to push out the timer.
Maybe.
I think so, because at that point you need to wait for the round trip to the resolver again.
Yeah,
that's a really good point. Thank you. Okay. All right, so that was asynchronous resolution. Now we're on to the second phase, if we remember. Boop. So now we're into the sorting address part. And to Ben's point earlier, when we talked about move on to the next step, we meant move on to this next step, not give up on old queries. Okay. So this is something we discussed a lot last meeting. There are different sources of preferences, and the discussion last time helped unpack these different preferences. And so when I was looking back throughout discussion, I got kind of these different sources out. So we have things like essentially what was Happy Eyeballs v2 and Happy Eyeballs v1, clients, particularly client implementations, people who love v6. They can prefer specific addresses. They have a preference for an address family. They have a preference for address options that they know historically worked better, or they know didn't break, or they want to keep reusing something. And those are kind of client performance-driven, successful connectivity-driven preferences. Then you also have another source, which is coming from the SVCB records, potentially somewhat implicit in old legacy ordering of DNS answers, but much more explicit in SVCB, that there are different priorities between sets of addresses. You can have essentially primary versus backup services, where you have explicit priorities ranked between different sets of addresses. And then you also have what we were talking about as like application requirements that we identified last time, kind of two key ones. There may be more, but properties about the connections like security. So like, do you have support for TLS encrypted client hello? And do you support QUIC or TCP, which is really going to be about the ALPN? do you support HTTP 3 versus HTTP 2, for example? And these are all different stakeholders and preferences you have for how you want to make a connection. And they're not necessarily always going to align, and that can be complicated. And previously, the 0.0 version kind of just smashed them all together and said, you sort them and you do this one first and you do that one, but then this one can potentially override that one. Like, it gets complicated. So that was not the right way forward. So the solution that we're currently proposing in 01 is to group and sort in like 3 levels of hierarchy. So you first say, so imagine right now, like we've gotten back all the answers and you're going to rerun this algorithm if you get more answers back later. But once you have a set, so once you've moved on, you say, I have a set of answers I'm happy with. You do first a grouping and sorting by your application and protocols and security requirements. So you can say, okay, I got back different groups of addresses that fall under different HTTPS or SVCB services. And all of these services support H3. All of these services support H3 and H2. These ones support only H2, or like these ones support ECH. These ones don't support ECH. And like you could have a full matrix of all of those different groupings, but like you essentially say things with very different properties about their security or their application protocols are different big groups. And then within those groups, if you have multiple services within a group that have the same properties, which is like, again, like hopefully you have a relatively consistent server deployment that like if you do ECH, you still have ECH for all of them, or if you have H3, you have H3 for all of them. So if they are the same properties, then you may have different priorities that have the same properties. And so you further group them and say, oh, this one, the server said is higher priority, this one's a lower priority. And then within those groups, you do the much more traditional happy eyeballs like destination address preference sorting, sort v6 up to the front, use your historical data. Lorenzo's in queue. I do just have like a visual of this in case it's useful to look at it, not in text, but in terms of pictures.
Yeah, so if it's easy for you to go back a slide, I think
I like the picture.
I like reading. I don't know. Okay. Okay, go for it. It's fine.
I don't care.
So I do agree that conceptually these sort of like we should have this hierarchy of what's important to sort by. And I sort of there was some debate between 2 versus 3, and there was like a bit of a tussle there. I think we probably all agree that 1 comes first. The problem is that 1 might rely on data that you don't have, like the A and quad A, versus the HTTPS record. Example, my understanding is that sort of today Chrome will race an HTTPS and a quad A, and it turns on ECH by default. But if the HTTPS loses the race, then it doesn't do it. And so that's an example about how the availability of information actually impacts this sorting. So yes. While I agree that like conceptually saying, okay, this is how we should sort, I feel that it's difficult to separate the sorting from the delays that we introduced in the previous stage, right?
Oh yeah, no, they're definitely related, and that's why I did call out like I think we still need to update things for like if you have this like hard ECH requirement that changes the previous algorithm, that you kind of have to wait for the SVCB answer before you move on.
And how would you do that? You sort of increase the delays.
We have an issue. Like it could be like a really long delay, or like I think indefinite is really dangerous. I think Nidhi will get into this.
Yeah. But there's a sort of interesting trade-off, right? Because if you want to roll out something like that, you end up being forced to do a trade-off of security and versus latency. But yeah, so I guess maybe we should just say that these two kind of like need to be really considered together. I do agree that conceptualizing only the sorting by itself as a separate problem is useful conceptually, but
right. Yeah, this is what you do when you have the set of answers.
Alessandro Ghedini, Cloudflare. So selecting the application requirements also sort of affects the source of the IP address that you select. So for example, maybe it's like a stupid edge case, but say you query SBCB and it says, I have ECH, and I have like an IPv4 hint for an IP address. But then the application decides, oh, actually, I like v6 more. And it tries to do ECH over a quad A v6 address rather than the v4 hint from the SBCB, then you run into the whole multi-CDN problem where you might accidentally connect to the wrong server. Is that?
That would be incorrect. So like you have your answers and your addresses are associated with the service information they come from. And so you like if you're doing ECH and you group that in group A and group B doesn't have ECH.
No, so what I'm saying is,
like and if the quad A, if all of your v6 answers are in group B, you do the v4 answers if you prefer ECH.
So I guess the question is, do you merge?
No, these are separate worlds.
Merge like SVCB answers hints with quad A or normal A answers?
Not if they're not related to the same service.
Well, they are related. So the problem we run into with SVCB is if you have, there's this thing that people do, which is CNAME load balancing, where you return the same, where there's like a DNS load balancer that then returns different IPs for different CDNs. The problem you have is if you query SVCB and that tells you ECH or whatever, that might come from one CDN. And then if you use the IP addresses for quad A record, then that might come from a different CDN. And then if you merge the two, then you have an issue.
So an SVCB author or someone can correct me if I'm wrong, but my understanding is that like with multi-CDN scenario, it would be incorrect to have your SVCB response with the like the dot in it that says I apply to the A and quad A answers you're getting right now include like ECH information if that information does not actually apply to your A and quad A answers. That's a misconfiguration of the
so
zone.
that I'm not saying it's a good use case. I'm saying people do this, and
so so people can misconfigure their service and you're going to break. Like, yeah,
right. But that's like quite frequent. So that was the whole point of IP hints in SVCB, because then you get your whole answer where you have ECH, quick, whatever, and then also the IP addresses that that application configuration apply to. So
I'm going to let other people in the queue
yeah.
also comment on that because I think they're probably in there for that. Jaroslav?
Right. So simplifying this probably to a healthy degree, the logic is primarily about figuring out what's the best option, the champion of all the potential groupings and permutations. However, some protocols support migration like QUIC. Some protocols potentially support multipath or will support multipath. Some protocols are explicit about address discovery, and others allow it to be an exercise to the reader. Is it something that this work maybe should take into account? Because I see here a potential to do perhaps, maybe we discover IPv4 address first, begin connection, and then see, oh, there is IPv6, which has better properties. So we could maybe migrate to it or do multipath.
I love that. I believe we declared that officially out of scope.
So will that be Happy Eyeballs v4?
I think that is very interesting and could be a good topic for like a recharter or like I don't feel like, I think that's a different document. That's different from initial establishment. We were talking about initial establishment. There's a myriad of things you could do on migration and multipath. I think that's a thing that could really distract us at this point.
Okay.
But I love it.
Microphones are fun. Yeah, my reading of the charter says that things you do later in dealing with multi-path, multiple connections, migration are all really interesting and not for right now.
Okay, so first of all, to Alessandro's point, that certainly isn't why I thought we added IPv4 and IPv6 hint, although I'm glad that it's useful in that case. I'm also glad I didn't know about this when we were designing SVCB, or the whole thing might not have happened, because that problem is like utterly intractable and horrifying. So I'm glad that we accidentally, or maybe deliberately on the part of other people, introduced a mitigation. I'm not sure what to say about it here. That's a real head scratcher. I got in queue here to say that I disagree with the draft's track on this business of ECH priority. And so I want to offer you the following argument. There is no sense in the client trying to, there's no sense in the client trying to improve the security level of the connection by overriding the priorities issued by the server. The security of the connection is a collaborative enterprise between the client and the server. And you can't improve the security of the connection by choosing different endpoints to connect to or deviating from the server's recommendations here. For example, in the case of ECH, the server could just disclose your inner client hello of its own accord. It knows the inner client hello, and it can publish that in a newspaper. So you can't improve your security by choosing to by overriding the server's recommendations and encrypting it when you weren't supposed to, basically, which is what I see here, where you have where we're saying we have a higher priority option without ECH, and we are deprioritizing it in favor of a lower priority option that does have ECH. Also, we are already sort of off the track here because the service B specification has a should for not publishing mixed mode RR sets. So you should never even be in this position.
I agree that we should not be in this position. Ideally, I think it is something that we should still talk about handling, because a lot of this is about like, what do you do when you hit different scenarios? And I understand that we disagree. And I think so like, this may be something that we want at some point, a consensus call within the group, because I know there are differing opinions on what a client is allowed to do for its own security purposes.
Eric, so in response to Alejandro's one question, the service B behavior is very intentional here. This is one of the reasons we designed it that way. You don't need the hit. If there are ways to horribly misconfigure it such that you do shoot yourself in the foot, but so for example, if you have that your target name that is in Quad A records has a mixture of things from different CDNs, then you've shot yourself in the foot. But if you've done the kind of a normal case where you have like a CDN load balancer that CNAMEs to two different things, or you have target names that differentiate between those different CDNs, which I think the draft talks about, then the address records are coupled with that particular service binding, and you should never have that mix and match problem. That mix and match problem is certainly present in the alt service case today, which is where sometimes we're like, things do run into problems there. That on the second point, I think I agree with Ben and I think it simplifies things to obey the priorities that come in the HTTPS record response and not try to separate those out, because the cases where you might include an ECH but is at a lower priority, maybe cases where that's actually really intentional, like operationally you're introducing ECH as a new thing and you're kind of trying it out on some servers and you don't necessarily want that first, I just put this record in to cause everyone to start using it, or you might use it along with some other kind of ALPN that's different as part of some experiment.
Mike?
Mike Bishop, not as AD, but as third continuous service B author in the queue. So yes, that is mostly what the hints are for, and it really shouldn't be deployed that way. And at the same time, I think this draft does have to contend with the fact that's a should, it's not enforced in the deployment model. So we might run into that. And if Alessandro is saying it's unfortunately common, then sorry, we have to deal with it here. I'm sympathetic to both arguments as to which one we should do first. I think the important thing here, going back to a previous part of the conversation, is that you can establish these buckets, and some of the answers you get back might result in entering new queries, issuing new queries that will later fill something into a bucket that was initially empty.
Yep.
So I think probably your algorithm is going to be more like go through these buckets, and if the highest priority one is empty, you might wait a little longer to see if it gets filled.
Yes, I think that was kind of getting back to the point of what Eric was bringing up previously, when we were saying we may need to extend the timer too.
Yeah. Yeah. As to do we put ECH first? Do we obey what the server said? I kind of think that has to be a client choice. Whether the client is prefer ECH, require ECH, do ECH if available. I'm not sure we should specify that here. That how much does the client care about ECH versus speed? The server's probably going to put the fastest in priority order.
Okay, thank you. Going forward, we already talked about this earlier, so for V6 only friends, we covered this, so I'm going to skip over this to let us get to the other things. Nidhi, come on up.
Hi, everyone. My name is Nidhi Jaju from Google, and I'll be going over the open issues. So the first issue is what we've already kind of been talking about, also filed by Ben, I think. And the current text, as Tommy mentioned, is that we group by ECH first, and then have the SVCB priority grouping underneath that. Whereas the SVCB ECH draft talks about how we should give the operators the responsibility to use priorities to prefer or not prefer ECH. And people have also talked about giving operators the ability to use lower priorities to test out ECH so that it doesn't affect a large number of users. My personal preference is to keep this ordering to maintain privacy. And once we've started a non-ECH attempt, we've kind of exposed the SNI anyway. So yeah, any thoughts from people? Or I can skip ahead because we've already kind of talked about it. Okay.
So I think it is worth looking at that text again, because it also says that the client's preference for different ALPN values overrides any server preference, which again I think is like operationally a mistake. It would mean that if the server has some reason for preferring these ALPNs, like I guess the simplest example is, I'm running on two backends, and one of them is much better for various reasons, and the other one is more of a backup. The backup happens to support a wider range of protocols. my clients might all use the backup if it has expanded protocol support. So if, effectively, this makes the priority mechanism only usable among identically configured endpoints, which I think is very limiting.
David Skenazy, if your backup doesn't have your feature set of your primary, it's not a backup anymore, it's a different server. But what I don't really understand here is, like, when you think of it as a client implementation, you're trying to accomplish something. And in general, you might have an API that says, hey, give me a connection for this protocol, because this is what I'm trying to do. I'm trying to talk this protocol to this server. If you have other lists that like don't speak that protocol, like you're not going to use them. So I'm not sure I understand Ben's take there.
Sorry, so let me attempt to clarify. The simplest case here is I have a primary server fleet and I have a secondary server fleet. Maybe I operate the primary myself and I outsource the secondary to a third-party operator. If that third-party operator activates Quick, and I don't have Quick on my primary, are the clients all going to like bypass my primary and go to the secondary? Like, I had that priority there for a reason. I don't actually want to send all my traffic through a third party if I don't have to. It's a backup.
Yeah, no, that's tricky, because if the client is just trying to send an HTTP GET, I kind of get what you're saying. But if it's trying to do something like, web transport over H3 and your backup only has H1, then that doesn't work. So I guess maybe we can massage the text to handle both those cases separately.
Jen, you had joined the queue and then disappeared. Was that an accidental disappear?
No, because I had a comment on the next slide and you keep discussing
perfect.
this, so I'll just wait.
Lovely, thank you. All right, DKG.
I'm not sure that I understand Ben's point either. I'm leaning towards the client is going to be able to choose its. I think the text is right here that the client should be able to choose its preferred security and application parameters. I wanted to also highlight that we haven't actually said whether the sorting should prefer the application over the security or the security over the application, right? There's even additional choices that the client will have to make about what it prioritizes. And no matter what the text says, honestly, there's going to be clients who have their priorities and they're going to stick with those priorities. It seems foolish for us to claim, client, you must obey the server's priorities, when the client literally will have their own, like, we know they'll have their priorities and we can't stop them from doing that. I think it's unrealistic to expect the client to not have its priorities. If the client doesn't care about whether there's a ECH or not, if it doesn't care about whether it's H2 or H3, then it just puts them all in the same bucket. But if it does care, of course it's going to prioritize it, and we can't stop it from doing that. I think we have to be realistic there.
Yeah, I just wanted to second that. The client will do what it wants, no matter what we write here. I'm not sure this is even going to be standards track, right? I don't think this is going to be mandating particular behavior. There's going to be a bunch of like timers and random stuff that's up to the client anyway. So yeah. The server operator can configure their servers as they choose, but they also need to be prepared for any client to do whatever silly combination of what they published and have to deal with it. Unfortunately, that's how the internet works. It might be better if it wasn't, but that is how it works.
Okay, so the next issue is one that Jen filed. It's about v6 mostly networks providing DNS6.4, and if we have a dual static host talking to a v4 only destination, having the choice between synthesized v6 addresses and native v4 paths. So rather than talking about the priorities here, I've kind of tried to lay out the different possibilities of what could happen. And Jen, please feel free to correct me. So we could have the dual stack where we can use the native addresses there, since the synthesized addresses will take longer going through NAT64 and using CLAT. And then we can have the v6 only scenario with NAT64 where we decline to use v4 in a v6 mostly scenario, where we use the synthesized v6 address, or we have v6 only with CLAT where we use the synthesized v4. So is there a situation where we would have a native v4 and a synthesized v6 address? And if so, can we just use the native v4 in that case?
Oh, Jelinkova, I'm a simple network engineer. All this implementation details scares me, right? Question number one, does Happy Eyeball system, whatever it does, it knows if the address is synthesized or not? Is it like always like clear? Because if you're using well-known prefix, it might be easy to detect. If it's network-specific prefix, how can you tell, right? Yes, I'm assuming implement. Like, yeah, so like if I like look at my laptop, I would know. But does this code that infrastructure knows that?
This implement, like parts of Happy Eyeballs already have discussion of cases where, you know, you got a v4 address from your corporate DNS, but then you have a prefix 4 from over there. So you already know what your prefix is and are looking at that in this code.
Okay. Good.
Could somebody repeat that into the microphone as well?
David asserts that it is a requirement for an implementation to know what the prefix 4 is. Is that fair?
No. There's parts of the algorithms that say, oh, find out what the prefix 4 is. So maybe, so yes, yeah. What I'm.
Okay, now I'm afraid we can. I might be missing something, but again, it's all matters when we start seeing cases of multiple interfaces, right? And then my question is, are we opening like kind of words related to PVD maybe? Like if you always send it through the same interface you did the resolution through, yes, it's definitely, I think, always better to use IPv6, no matter synthesized or not. But the cases like VPNs, it might be better to prefer v4 because your v4 might not be reachable through an interface you did the resolution through. I'm not sure, how do we deal with multiple interfaces and sending DNS through one interface and sending traffic through another? Is it like in scope? Is it covered like, or am I asking something, or am I confused? Yeah, so is it within PV? Okay, well, in this case, I assume if we might consider, I don't know, like corporate VPN and your native interfaces, different PVDs, are we? I don't know. Okay, in this case, yeah, I would say IPv6 is always better, right? Because first of all, then you don't. Yes, I am biased, yes. But I mean, the reason is, why do we want to do another layer of translation, even if it's stateless, like CLAT, right? Why don't we just send IPv6 and like be done with it, right? Because we assume we have that connectivity. So yeah, because all corner cases, I believe, will be related to cases of multiple interfaces, and if MPVD going to save us, then yeah, let's just use v6.
Andre?
Andre Saladka, RIPE-NCC. So yeah, I have a lot of comments to this. First of all, as much as I love IPv6 mostly concept, I feel like it's more or less out of the scope of this draft, because IPv6 mostly is about how the network works, but this runs on a host, and the host is either dual stack or IPv6 only with NAT64, or IPv6 only without NAT64, but that's outside of this thing. But basically, as a host, I don't care whether the network is IPv6 mostly or IPv6 only. For me, it's IPv6 only or IPv6 or dual stack, and it's based on what my operating system or my DHCP client decided for me, not for my within my Happy IBOS library. And with that, I actually think that it is quite good idea if you can do it, but of course it's extra work for the Happy IBOS library to undo synthesized IPv4 address. So if you end up that you are running on a machine that is running in dual stack mode on IPv6 mostly networks, which means that you will get both native v4 and DNS 6.4, which will try to send everything through v6 through NAT 6.4. I think you should undo this synthesize and use native v4, because the fact that your computer has native v4, it's not true that every single IPv6 most network uses NAT4 for the dual stack. You know, IETF network, for instance, is one of the cases where you give native v4 if you are running dual stack. So the worst case is that the native v4 will go through the NAT4.4 and the synthesized v6 will go through NAT 6.4. Yes, CGNAT is NAT 6.4. That's the same thing, except for what is translating. So basically, if you always use synthesized v6 address, you will always go through NAT 6.4 and you will never avoid it. If you deliberately use native v4 if available, you might go without any CGNAT because it depends on what kind of network you are in. And the worst case is you will go through the NAT, which is the same thing as NAT 6.4. So it will not be worse than what you will get with native v6.
All right, Tommy?
Tommy Polly Apple. I think I agree with a lot of what Andre was saying. I find, so I would love a little bit of comment from you, Jen, because I find this issue deeply confusing. Because I don't know who it applies to. So like in the issue, it's talking about like, you know, should we pick between a synthesized v6 address or a native v4 path? So like I'm imagining here, like either you're a case where you're on a v6 mostly network and you are not aware of how to do you know, CLAT, or you don't know how to do Pref 6.4, like you don't know how to, like you're falling into the dual stack case. In which case, I mean, A, you're probably not doing this algorithm, but also like, yeah, you have native v4, you're just going to use native v4 because you're a naive client. You don't know how to do synthesis, because if you did know how to do synthesis, you would have been v6 only. And then if you're v6 only, you don't have a native v4 option to begin with. So if you're doing anything with v4, you're always going over the synthesized NAT 6.4 path because you chose to be v6 only on the NAT 6.4 network. So it seems like I just don't see like what is there. So Lorenzo asked, what if there's a DNS 6.4 on your dual stack network? That is a weird configuration, but I'm assuming that in this case, you as a client, if you're somehow a Happy Eyeballs v3 client who happened to be in this configuration, then from your perspective, if you were a dual stack client, you are not v6 only aware, you're not synthesis aware. Maybe those v6 addresses you're getting back are technically going through a NAT 6.4 or whatever, but you don't know that. And like, you just run the normal algorithm. I don't think there's any client behavior change in that case. It just is like a weird network configuration that just happens to have some side effects.
All right, Mike.
Mike Bishop, again, no hats. I can give you existence proof of a dual stack network that has DNS 6.4 because I've set one up. It's interesting. But I think Tommy's point that this is happening, this is outside of the scope of this document, I think it goes further than the point you made. Because if you're on a network that has DNS 6.4, then the DNS server is going to generate quad A records for you if there aren't any. And so from the client's perspective, that host is v6. It's v6, you connect to that address, and the fact that you're being sent through a v4 NAT is a detail of the network that the client doesn't need to have any visibility to. If the client is using CLAT, that's not something that the application needs to deal with. From the client's perspective, it's dual stack. If it gets back an A record, it's going to try to send to that A record, and then below it, trying to talk to that v4 address is going to turn into v6 traffic on the network. From the client's perspective, none of this matters. The client is either dual stack or it doesn't have an address in one of the families. It looks at the DNS records it gets back, and if it gets a record back and says, I don't have an address that can talk to that, okay, scrap that record, I can't use it. It's really a lot simpler than this conversation is making it. One place where I think we are oversimplifying a little bit in our conversation, though, v6 over v4 is actually not a hard, I won't say it's not a hard requirement, but it's slightly more complicated than that because non-local ULA addresses are less preferred than v4. Often they don't, but so we previously had said all ULA addresses were below v4, and we just had a document past the IESG that moved known local ULA addresses above the v4 split. But still, it's worth noting that there exist v6 addresses that are less preferred than v4.
Jordi Palet. I am not sure if I am missing something, but I feel that we are overcomplicating the thing here because basically what we want to do is which one wins, IPv4 or IPv6, that's it, right? So it doesn't matter if it's synthesized or not.
Let me try to be constructive for once. It sounds like where we are is, if you're dual stack, you're dual stack, and you just do whatever you get told. If you're v6 mostly, you know that you're v6 mostly, and you do the needful. It sounds like this is where we're going. What that means, what it does mean is in a dual stack network with a DNS6.4, you'll prefer the DNS6.4 over native v4, and maybe right because you're unaware of it. There's a DNS6.4. You get a synthesized quad A. You're like, oh, look, a v6 address. Cool, let me use it. 6.4 FF9B. Oh, that's a v6 address. And you're blissfully unaware of it. So in that case, yeah, then we basically simplify it, and we basically say, okay, if you're v6 mostly, then you know that you are, and you know that you're v6 only, and you really only have one thing to do. And yes, undoing that. I guess you do have to choose between these two. You can choose the synthesized v4. You can undo the synthesis, or you cannot. It kind of does a little bit change because it's a v4 socket versus a v6 socket, but for something like this, it probably doesn't matter. So I guess we need to reduce the cases to two, right? We need to say v6 only and dual stack, and that's the totality of cases. Okay.
Thank you.
All right, Eric, we closed the queue. Do you have something that's urgently pressing?
I'm going to have a quick response. For the second column, there's a big difference between the DNS6.4 synthesized ones, which would kind of be mixed in, versus ones where the client synthesized them, where you definitely would want them lower priority.
Okay, so the next set of issues about downgrade attacks, if we start connection attempts without SVCB information, an attacker could potentially interfere and target ECH or HTTPS information and effectively cause a downgrade attack. So in the ideal case, we send a quad A and SVCB query, and we get an ECH config in the SVCB response and use ECH to the origin server. But there could be an attack where the attacker can guess which packets contain the SVCB information, and note that this probably only applies to secure DNS scenarios, because in clear text DNS, this attack is trivial. And so the client could time out while it's waiting for the SVCB information and proceed without any ECH config, and not use ECH when it could have. This also applies to the HTTPS case, where the attacker could drop the HTTPS information and we time out while waiting for it and proceed without TLS.
sorry, clarification. You're saying that in these two slides, you're saying that the attacker is an on-path attacker that is able to like figure out which of your packets are asking for an HTTPS record.
Right.
So they're somehow able to subvert the encryption. And wouldn't you have head of the line blocking though anyway? So if the HTTPS was issued first, then the A and quad A wouldn't come back, right? I guess mostly it was a clarification question. So you are basically saying, yes, you're basically saying the network is able to pick out of your encrypted packets that one which it knows somehow has the HTTPS record and drop only that one without dropping while still letting through the next ones.
Right, yeah.
Which I don't think you can do over DOH, maybe, can you? Or DOT for sure.
So can't the attacker be between recursive and authoritative as well? In which case, DOH doesn't matter.
Which case, game over? No.
No. So the attacker could be between the recursive and the authoritative, and only doing the HTTPS answer.
Maybe I can.
Yeah.
Ben, do you want to?
Maybe I can clarify. So yes, this attack is possible in DOH with HTTP3. The attack is possible with probability 1 out of 3, or maybe 2 out of 3. If you see 3 flights go by, and you drop 2 of them, you've got a 2/3 chance of having blocked the HTTPS query while allowing A or quad A to go through so the connection can proceed.
That's going to work real well. I had another comment. I think for the case where this is not an encrypted channel, I think we declare that this is sort of infeasible, working as intended, right? Yeah.
Yeah. So the proposal here is if we're using secure DNS and we've sent an SVCB query, we could require a response before proceeding, but this also raises the question is if this is safe or if this is just going to lead to indefinite stalls. And an option for that we've discussed is maybe introducing a longer timeout so we don't indefinitely stall, but would like to hear thoughts about that. And obviously, as Lorenzo mentioned, for the clear text DNS case, we don't wait beyond the existing timer since the response is already unprotected.
If we're not using DOQ, which I think we kind of don't right now, is there a way to try to defeat the attack? Or is there, like, if we can sort of like generally find a way to mostly mitigate or defeat the attack, then we don't have to answer this question. So that's why I sort of, I get the 1 out of 3 thing, but if you, for example, were to send the 2 DOH queries in the same quick packet, which I guess maybe should be possible, then that sort of naive attack wouldn't work. So I mean, that's just like a, so yeah, if we can sort of like, or if we have ways of mitigating, then maybe we cannot answer this.
Ben?
Yeah, so this is, so as a matter of process, this behavior is specified and mandatory in RFC 9460 service bindings. So any change here, in my view, would require an update to 9460. And as a technical matter, I would prefer to say, no, you have to block. You have to wait, or you've defeated the whole thing. And I think that finally, as a practical matter, you have to remember that the attacker here is very patient and doesn't mind if they're delaying your requests by 500 milliseconds or 1500 milliseconds, if that's what it takes to get past your timer and disable your protection.
I just wanted to follow up on the mitigation mechanisms that might be available here. So the cramming all the queries into a single flight and therefore into a single quick packet, or a TLS packet if it's DOT, is only half of the question. The responses also have to be coalesced. And as the client, you can't guarantee that the responses will be coalesced. If the both, basically, you need both. You need either coalescing all the queries and coalescing all the responses, or you need the packets to be indistinguishable from one another, which means you need adequate padding on both the queries and the responses. But the coalescing is the only way to make sure that they actually come through all in one piece, and both sides need to do that. I don't think we can get guarantees that our DOH recursive is going to coalesce all the answers. The DOH recursive is probably going to try to answer the ones that it can answer promptly, and those might not all be in cache at the same time.
And Lorenzo for a final comment.
Yeah, just wanted to point out that if we want clear text DNS and encrypted DNS to behave differently, that's kind of more complicated. It means the DNS resolver has to know and change its retry algorithm and so on, depending on, what we are doing, right? So this is more complicated to do. But yeah. And that's something that may not be obvious, because if you have a layered or modular architecture, then you probably wouldn't implement it that way unless we wrote it clearly.
Okay, the next issue is about timing for retransmission and next connection attempts. So in the draft, we currently talk about a connection attempt delay, which is the time we wait until we start the next connection attempt. And so the question here is, should we start the retransmission first, or do we start the next connection attempt? And this is a question because this could exacerbate packet loss if we don't have packet pacing. And the options here are, do we send the first retransmission first, because we obviously preferred the current attempt for a reason, or B is to send the next connection attempt first because the current attempt is maybe being slow, and so we want to give the new attempt a chance. Tommy.
Just quick comments. I don't think we're going to solve this here right now. I'll point out that I think we get into this in the issue, it's hard to actually do this because depending on where your retransmission is happening, could be in the kernel, it could be very hard to coordinate with kicking off the next connection attempt. So all of this is best effort. And this also may be a thing that we want to do measurements on, kind of like the other thing, that this is a case where we should do some targeted studying to see practically what is happening today in people's happy eyeballs algorithms and what are the effects of changing those values, and how often do we actually see harm from them being close, and are they even close? Are we getting it right?
Yep.
All right, David, nice and speedy.
Plus one to what Tommy was saying, just want to say that this dates back to Happy Eyeballs v2, and the way I implemented it back then was I pulled up the source code for the kernel and the TCP stack, went, ooh, that seems fine, copy, paste into the user space code that was doing Happy Eyeballs, and ta-da, we're sending it roughly around the same time. It's the same retransmission. Of course, other people probably modified that kernel and this there, so there's absolutely no guarantee. Having a recommendation that that's kind of the headspace to be in is helpful, but again, like people were saying, there's no way to guarantee it, and that's fine. This doesn't need to be perfect.
It's just a recommendation. Okay. So the next issue is about our interaction with service priorities. The first question in that issue was, can we raise connection attempts across multiple service priorities, or should we wait until all the higher priority endpoints fail? So the current text in the document talks about this grouping by service priority, and then the fact that we should start all the attempts in a higher priority group before we start the attempts in the lower priority group, but we don't necessarily wait for them to fail. So the options here are, do we just keep the current text and allow lower priority attempts to proceed since the sorting ensures higher priority attempts start first, or do we want to change that to wait until failure? Yeah, any thoughts? Tommy.
I feel pretty strongly about keeping the current approach that you keep falling back. You don't wait for some dramatically longer time or wait until failures. Because when we're talking about failures here, like TCP timeouts, we're talking about 90 seconds. like enormous times. If your server configuration is such that you have different priorities and your top priority list has like one address in it that's not responsive, and then you have a ton of other addresses that are lower priority, you kind of did that to yourself. And like generally, like I think in a normal configuration, you're going to have a normal size set of addresses in your highest priority. That is your most preferred thing. And realistically, falling back through like, what, 8 addresses takes some time anyway. And if none of them are responding in that time, then it's probably about the right time to try the backup.
Ben?
Hi, I agree with Tommy. In general, what I really want here, and maybe I'll try to write some text, is that we should have a target for an upper bound on the false positive fallback rate. So basically, all else being equal, any implementation that has a false positive fallback where it bypasses the primary and goes to the next priority level, even though the primary actually was reachable. Any system with a false positive fallback rate less than, say, 5%, I think is good enough. So the important thing here is that there should be some clear and strong bias in favor of higher priority options.
Thank you.
Okay, so the second question is, how should we use the historical information to interact with service priorities? So if all the addresses in a priority group have failed previously, what should the client do? The first option is to not skip the group and run like we normally do. B is to sort the group to the end because we don't want to encounter the slowness or failures that we've encountered again, or I don't know if there's anything else.
Tommy Polly Apple. So Ben, I'd like your input on this. So, because this is again going off of one of your original issues, we kind of rewrote this discussion in light of the grouping, because previously we didn't have good ideas of grouping and we weren't following the priorities correctly. Now we're doing a better job. I think, previously, it would be bad if the historical information was just like, oh, one bad historical thing made you sort things differently, and then you ended up inverting your priorities. I think what's remaining here, so like in the current algorithm in the document, it's saying you do that historical sorting within a group. And so it's like, yeah, if you know in your highest priority set of addresses, one of them always is not working, or these are not working, but these other ones are, like, great, you're still respecting the priority, you're still doing the right thing. The one edge case we want to clarify is like, what if you do have historical data that, like, come on, every single time I've tried all 8 addresses, they've always failed for me. I keep falling back to the fallback. Should we have something where we can learn from that and just say, like, you know what, at least on my current network, this thing just doesn't work. I'm going to switch to the fallback preemptively.
Yeah, so I think that my guiding principle here again is the same. Like, the goal is to minimize the false positive fallback rate, balancing that against basically the successful connection time in cases where the fallback actually was necessary. And there's a tuning question of finding heuristics that balance those two forces. So I don't actually think it's necessary to be super strict. Once you have some information, it's not so important to be super strict about trying each group in priority order. What's important is that you don't get permanently stuck because of a small number of bad measurements in the wrong state, where, like, priority 1 failed, priority 2 worked. From now on, you have history that says priority 2 works better. You always try it first. It always works. You never recover and go back to priority 1. So I would just like to see whatever we specify have some convergence property where it will statistically eventually go back to option one if option one is actually working.
Okay, thank you. I'm going to try to speed through the last issue. So this is about target fixation. In the draft, we currently have some text about letting the client prefer previously used addresses. And there's a concern about how that causes stickiness, where we repeatedly use the same addresses, even if we get better options. And so we now have the text around grouping by service priority, which means that the stickiness only happens within the group of addresses with the same priority. And so servers can adjust priorities if they want to shift clients around. Is this sufficient, or do we need to do anything else here?
Anybody want a thumbs up, thumbs down in the room? That being the most time efficient way to. Cool, I'm seeing a couple of thumbs ups. Great.
Okay.
All right, thank you.
Cool, thank you.
Very nice. All right, next up. Aha, Lorenzo's here.
I
Go for it,
have
Lorenzo.
a sort of unrelated question. Related to the discussion we had before about SVCB and Quad A. So the draft right now says that, you have to do SVCB first, then Quad A and A. And that you're sitting duck for the target, for the attack that, Ben mentioned around I'll just drop the first DNS query in every group. Do we want to do something better than that? Because especially when you're using encrypted transport, we should try, should we try a little bit harder to sort of make the SVCB or the HTTPS query survive? And because even if the answer is let's punt to a future discussion, the text that we have right now is very prescriptive and very precise. Basically says you have to send them in this order. You can't randomize them. You can't coalesce them. Maybe you can coalesce. But I think that's something, I don't know, that's sort of more of a question for the room, to be honest. But
yeah, I think that is a very good question. Could he ask you to file an issue for that? And Ben, I saw you hop in the queue briefly. If you don't mind hopping on that issue, and it would be good to dive into the details there. But we do want to get to some of the
sorry,
other
to clarify,
questions.
you want me to add a new issue, right?
Yes, please. Yep, thank you. All right, Dave. Slight time compression here, but what else is new?
Cut it down to 10 or something. Hi, everyone. I'm Dave Plonka. I'm the, is that what you said? Did you put the time up? Would you mind doing that? That would help. I'm the co-chair of the Measurement Analysis for Protocols Research Group. And it happens Miria Kuluwind, our other chairs here in the room as well. Part of this, I'm representing the research group just in the coordination between HAPI and the research group to help provide measurements for your effort here. The other things they're saying are just my own mistakes, and that's me on a personal basis. So keep that in mind. MapRG was in the hackathon 2 times in Bangkok, and then again this time for this effort, focusing on Happy Eyeballs, and also bringing this device up in the upper left, which is the Internet to Build IPv6 test pod that provides 5 different IPv6 transition environments on different SSIDs. This time, we just had a couple people join in, and both from RIRs. Jeff came and helped out with it, and Carlos came to test some of the transition mechanism stuff. It was more productive than I expected, and I'll show you why. The 3 things I want to share with you today are what we did in the hackathon, some tools available to you, some new research into measurements about Happy Eyeballs as it exists today, and then I want to extend an invitation to you to work on some brainstorming ideas we have about where this could go and how I think it would be a benefit to implementers of HAV3, and then what we could do before the next meeting. So first and foremost, I want to let you know that there's this peer-reviewed research paper that will be published in October, but it's available to you now, both on archive and from these authors. The lead author, Patrick Statler, is in the meeting remotely today, and I've been talking with him over the last few days, kind of forming some ideas about how we might coordinate work to help HAV3. But good paper, it's only 6 pages long, so give it a look. If you don't give it a look, I'll give you a glimpse of what it shows in results here that was eye-opening to me. Like, I read this just before the hackathon. So they have a results matrix here, And the gist of it was sort of like the black filled in dots are good things about, meaning these implementations of browsers seem to comply with HAV1 and HAV2 mandates about the connection attempt delay and lesser so the resolution delay in V2, but a lot of them don't do any of this stuff. So the paper's a fun read from that perspective, because I was under the misapprehension, and I brag a lot about the V6 deployment and tell people in the world why V6 works well today. It's because of happy eyeballs. That's clearly not the case. It's things that are in the spirit of happy eyeballs maybe help out, but there's some nice results to look at there. The other cool thing that this team has done, not only did they do lab-based measurements of all these different browsers and environments, they put up a website that you can go to and do this testing with your own browsers and see what it's doing. So certainly that was awesome, right? Because now there's a tool that I can just access remotely, and that's what I did in the hackathon. And I was able to get some results that, first off, using their tool, get results in a completely different environment than they'd been before and reproduce their results. And what we're seeing here, it's a little bit of an eye chart for you, but if you go there, first off, it's very privacy minded. So if you do use the tool, really consider putting in details in the description line, telling them who you are, where you are, and what you're testing, so that they can better interpret the results they get. But this is hundreds of milliseconds left to right, and it's exploring the connection attempt delay and showing sort of what we see. The green is doing V6 up until they delay the connection attempt artificially on their server, and then it falls over to back to V4 the way you'd expect. And here I'm working on the IETF network, the one that presumably most of you are using now. Then I switched to an environment on that little device, an IPv6 mostly environment, and I got this result that showed, and I'm in the description, I changed it to say I'm using this other SSID and Wi-Fi network now. And it's showing about, when they were delaying the connection by 50 to 100 milliseconds, it's falling back to V4. And so you might wonder, well, why would that be? So we already found something interesting. And the reason was because when I'm using that other device, I'm tunneling V6 back to the United States at Internet 2 so they can provide these features. And then it's coming back to TU Munich where they have the server and making a very long path on V6. So one of the things I discovered is currently the tool coalesces or conflates the round trip time with the delay. So just something to understand about the way the tool works right now. Then we can switch to another browser. Here I'm using Safari instead of Chrome, and we get subtly different results. Safari's a little sporadic, and they note that to some degree in their paper. But I also see that, for instance, with that long RTT, half the time under Safari, it just used V4 instead, even though it was in a V6 environment. So, so how does this all work? Well, interestingly, it is a parameterized DNS zone that they use where they can specify the delay in there. So think of from a tool making perspective, what we would have available to ourselves if we were testing a prospective implementation, if we could just dial up the amount of delays we wanted for the HTTPS query, for the quad A, for the connection attempt, all those things can be parameterized in the way they do these queries there. So I'm using DNS top to look at what it's doing while it's going along. And I don't have time to show you the second set of results, but there are certainly some weird results like this oscillation back and forth between V6 and V4 that Safari does. But that's all historical. Let's focus a little more on the V3 stuff. I have this slide in here because similarly, the stuff that Jeff Houston and AP Nick have been doing for a long time to study V6 usage, it does the same thing. It puts hints in the DNS labels like this. Let's see where. There's a D right there, and that means it's going to give dual stack answers back to the client. So just like APNIC surveys the world for when clients choose to use V6, this tool that the TU Munich folks and this team of authors have created can allow us to do that moving forward in the V3 development environment. So going back here, I said Patrick's online there. I've been talking to him about some ideas. I think we could add, they've focused on making it a survey so that it's easy for users to use. But what if we had a mode that's easy for power users to select exactly what they wanted? So all these things, we're trying to navigate our V3 RFC right now. And certainly some people want to tweak it differently. If you could handpick those characteristics on the website and get it to deliver, get that site to deliver both the authoritative DNS requests and the behaviors from the website that you wanted, it'd be really useful. And then the last challenge or the invitation is, I think we can really make a lot of headway on this by the next meeting. I told Patrick that they're going to be presenting the paper in my hometown at the end of October, just by chance. I want to set up one of their happyeyeballs.net things in North America, so we don't have this round trip time problem with one they have now. And they've released their stuff as open source, and I think I can get help from that team to deploy that. So if you're interested in doing something like that, let's get that done before we go to Montreal. That's my network and where I am. It's not so far from Montreal, so I think that will work well for us testing in Montreal. And just think about how these tools could be enhanced to help our effort here. And please join. I need another champion in Montreal for the hackathon, because those two events are back-to-back days. The IMC ends, and then the hackathon's the very next day in Montreal. So it's going to be a challenge for me to be there the first day. So I'd love somebody to help with that.
David is in the queue.
Beautifully done on the time. So first, thanks, Dave, for the presentation, but also thanks to the folks who built these tools. Holy crap, this is amazing. Yeah. Just to share a very short story, part of what led to the creation of Happy Eyeballs v2 was Jason Fessler, who was a known IPv6 enthusiast, built a small tool. It was a web page, and he showed me, like, look, in Safari, you're doing 50% of your connections are going over v4, 50% over v6. We want more v6, but it was really the tool that made us realize, oh crap, you're right. We never really thought about this. So this tooling is really critical to the work we do. Like, I know, like, folks on multiple network stacks here in this room are implementing Happy Eyeballs v3, and this is what'll make it the best thing ever. So thank you for this work. Please keep doing it. I love it.
Yeah, thank you. I would second that. Both great presentation, and also when I saw this tool earlier this week, I went and clicked on it a bunch and got some really interesting things in my browser. Yes. Let me get it set up.
Okay, so first point I want to comment. This is not about any existing document. This is not pushing for any existing solution. This is just to show what I think are open questions that I think we need to clarify before going into a real document for the reporting solution. I think I restarted pushing for this at the time we were working on Happy Eyeballs version 2, maybe about 2016 or something like that. We have different documents. At that time, we got some pushback from, actually it was discussed in B6 Ops. The main pushback, I think it was privacy considerations. I don't really agree with that point, but this is not the point here. But I just want to make clear that I am not pushing for what we worked before, okay? I am just trying to make a lot of questions to ourselves so we can fix the way forward. So the first point is from where we are reporting. I mean, is Happy Eyeballs implemented in the browser, in other applications, in the operating system? So that's very relevant, because depending on that, we have a different impact also in the implementation of the reporting solution. For example, I guess it's easy to use the solution for reporting that was presented in the previous Happy Eyeballs, Happy working group, which was W3 reporting API. But I am not sure if this is a good way to implement in every possible application. If it's done in the operating system, then probably yes, okay? So that's the first question. Second one is what we want to report, because probably there are many things. David?
Do you rather we discuss this at the end, or do we want to take answers to the first question?
We can go point by point. Yeah.
Then just David Skenazy, Google. So Happy Eyeballs is implemented in the network stack. So that's a nonsense term that doesn't mean anything, which isn't particularly helpful, but it's implemented between your HTTP API and your kernel sockets API conceptually. And so in general, that means it's in the HTTP stack. You could conceivably use it for non-HTTP applications, but in practice, the only folks I'm aware who've like gone through and implemented this are ones that have an HTTP stack. So for Chrome, that's part of the browser, but recently we shipped Chrome's network stack as a library on Android. So conceptually, the Chrome network stack is the Android HTTP network stack with some asterisk, and that's a longer story. Apple did something similar, but in the other order where they built this in the HTTP stack, and then Safari uses their HTTP stack. But conceptually, that's where it lives. That means that that code knows what HTTP is, so the people writing it know what the W3C is. That's an option, even if you think of it as a layer violation. That's just how it is in practice.
But this is actually in part my point. You see, there are different ways to do that. I don't know if we should then recommend something for the implementers where we want to have Happy Eyeballs implementation, because if I understood correctly, what you just said is that basically it's only being able to source problems for HTTP, but other applications not.
So and Tommy's going to come here to say that his HTTP stacks also speaks TCP, but a recommendation isn't going to help. Like the reason that Apple built it in one order and Google built it in a different one is Conway's law. We all ship our org charts, and where this lands based on the team that it's in, and that's just how it'll be. We can make all the IETF recommendations in the world.
It will not happen. Yeah. Okay.
Just for Tommy and Polly, for the record, like I do not think it's specific to HTTP. Like, yes, yeah, HTTP stacks are very common. There are a lot of the traffic from clients, but I mean the way we do it for our networking stack, like it is a generic layer. So like things like doing doing doc or whatever, like those things themselves use Happy Eyeballs to talk to the resolvers. So there certainly are other categories of well-known applications like DNS that themselves will use Happy Eyeballs. So I think it is a question, if you're talking about reporting, that there could be different streams of types of applications, and maybe you have different solutions for different application types.
Yeah.
Is David in the queue next? Oh, no, sorry. Dr. Nygren, I think there are two dimensions to this. I think one dimension is using clients that do support HAB3 to find brokenness that could be fixed for other purposes. I think and from that, I think just capturing in browsers is going to cover a lot of the end user cases, because the cases where this ends up being the most catastrophic is really old clients running a version of Chrome from 15 years ago, running on some set-top box that break with v6 and cause people to make switched content to BV4 only. So I think, but getting the browsers to get telemetry from that, from things that aren't that old TV will help. And the other class of things which the browsers won't help for, but is a trickier challenge, are going to be things that are running in server environments. Like if you have something running in a cloud environment and that, like some API call is breaking, browser related stuff isn't going to help you there, but that may be that operationally there's a better way that people should be monitoring rather than relying on the browser clients to collect that data.
Okay.
So Geordie, we're almost at the end. Pick the
sorry.
slide that's most important to you. You've got 6. Pick the one you want to talk about the most.
I didn't catch you. Tim.
Just a quick time check. You've got about 4 minutes and 6 more slides. So.
Okay. So maybe we should stop the discussion and bring the discussion to the list. So go to report. And this is important because depending on what we are reporting, the responsible for the brokenness is in a different place on the network. Okay, so also when we report each failure or aggregate them, for example, by number of failures or by time, or every n minutes or whatever. Okay, so that's another decision that we need to take. To whom we report? Because in my experience, the problem may be in the ISP of the client, it may be in the transit, it may be in the content provider. So maybe we should, let's say, decide who is the main responsible for each kind of brokenness, and maybe that bring us different reporting solutions. So that's a difficult situation probably, or let's say more complex situation. So yeah, that's what I just said. Different. For example, in the case of ISPs, they are used to syslog, okay, but they are probably not using the W3 solution, and it will be difficult to enforce them to get the reporting by means of W3 solution. If they are not using it, they will not probably invest in making that a production thing for them. Privacy considerations. As I said at the beginning, this was the main pushback at the beginning, but we commented also in the previous Happy Working Group that the W3 solution also has some privacy considerations. So we are in the same situation here. I am not really sure if we can live with a reporting solution that don't really provide the source of the problem. So I mean the client address. Maybe if we just report, hey, we have this destination broken, it's more difficult and less feasible to investigate what is the real problem, but it gives us some chances. Maybe then we can only solve, let's say, 50% of the brokenness, but that's better than nothing, right? I am also not sure, because previous discussions that we have, for example, in B6Ops regarding carrier rate NAT, that if we are using addresses from clients for operation and management, that's a real privacy implication, because we are not disclosing that. We are just using that to fix the problem without disclosing any information. So that's probably a discussion that we need to have as well. And I think that was basically, then integration with Happy Eyeballs version 3. If Happy Eyeballs version 3 is going to standards track, do we want to have as mandatory also that a Happy Eyeballs implementation also requires a reporting implementation solution? I think yes, because otherwise we are going back to the situation we had the last few years. So I really think that we must probably, I am not saying to stop Happy Eyeballs version 3. What I am saying is when we fix the reporting solution, we have there maybe an update to Happy Eyeballs to say that any Happy Eyeballs implementation must also include the reporting solution. I know this is conflictive, but that's my perspective. David?
I know we're over time. I'll be very brief.
Yeah.
So on the topic of must, you can put as many musts as you want. Unless we have a protocol police, it won't make a difference.
Yeah.
On the topic of privacy, I think if you want a reporting solution, you need to figure out ones that the implementers are comfortable shipping in terms of the privacy impact to their users. So I'm happy to brainstorm that with you. Like, to give you an example, sending both the source address and the target destination, that's conceptually the browsing history. That's definitely a no-go. But I think what would be helpful maybe for the list or for your next presentation is to give us examples of breakage. Tell us stories of, oh, our network fell over in this way. Like, I don't know, does it mean that the router had a weird bug where it was only routing v4 but not v6 and Happy Eyeballs papered over the problem? Like, help us understand what's the failure mode and what are these things you want to fix, and then we can brainstorm together what kind of solution for those. Because right now I have a trouble understanding what it means for my network to be broken, half broken.
Well, I think the actual document, the actual Happy Abels draft, already has a description of this brokenness. So yes, I can find specific examples. I think it's not a big problem. So that's it. I think, especially because we run out of time. Probably I am going to wait for the minutes, and then with the minutes, start a discussion on the list in every specific point, if you agree. Yeah. And that's it. Okay, thank you.
That'd be perfect. All right, we are at time, and our last question is, would anybody be interested in a set of topics to have a interim? Last time we said, let's make a bunch of progress on the list and then do an interim. We had some really good discussion right now, and I think it'd be nice to close on some of those issues. And there were definitely some details that I think we all kind of wanted to work out. So can I get a quick thumbs up, thumbs down in the room and in the chat about doing an interim on the main document? Wonderful. All right, let's write that down as about 8-ish. And I'm not seeing any in the chat yet. And then same question, but for digging through some of the details on reporting, and we can potentially invite additional folks from some of our different privacy focused areas for that as well. Cool, let's make that 6-ish. Wonderful. Thank you all. Sorry for going slightly over time, and have a great rest of your week.
Thank you very much.